We can practice determining which of these formulas for ionic compounds is incorrect by using the periodic table to look at the charges of the cations and anions that make up these ionic compounds. So using these left two columns, we know that the alkali metals will be +1 charge and the alkaline earth metals will be +2. And then going over here, we have the +3 cations. And then if we think about the anions, we have these final three columns here. And the noble gases, of course, do not form ionic compounds. But with the halogens, we have -1, then moving over -2, and -3. So if we go through each of our response options, we can first write the charges for our cations and anions. So for the cations, we see that strontium is +2, cesium is +1, aluminum is over here with +3, and then that repeats. And then we have calcium, which is a +2. So now if we go through our anions, we have chlorine, which is -1. We have sulfur, which is -2. Chlorine again, which is -1. Phosphorus, which is -3. And selenium, which is -2. So let's go through and see how these match up. So since we have +2, -1, we would need 1 strontium and 2 chlorines, which is correct. This next option, we would need 2 cesiums and 1 sulfur in order for them to balance, so that is correct. We have aluminum, and then we'd need 3 chlorides to balance, which is correct. And then we see here that it should just be aluminum phosphide, but we do not have that. This is giving us an unbalanced option. So we know that this is incorrect, and our final answer will be D. And just to do our final check, our final option is balanced in charge, so it should just be calcium, selenamide, which I've never heard of, but those are our options.